Hello, I'm Hu Mengxiong, EGE2409009, and today I will show you the application of the calculus. Today we have three questions. The first question is the application of the derivative to economics. And the second question is what's your method to find the volume of the solid of the radiation? The third is the moment and the center of the mass. First chapter, I will show you the application of the derivative in economics. And in the economics analyze, we have three common function, which is the cost function and the average cost function, revenue function and average revenue function, profit function and average profit function. Average function is to calculate the cost of the producing some units of the product. Revenue function is to calculate the revenue of the selling some units of the product. Profit function is to calculate the final profit when selling some units of the product. The application of the derivative in the cost function is to find the lowest cost. This is a very common method. Which means that when we have the derivative of the total cost function with respect to field, we can find the lowest cost product method under the current state by finding the point where the derivative equal to 0. Which means that we can have an example. His academic name is marginal cost. The cost function usually be defined in this way. The cost responds to yield equal to the cost which is fixed plus the k is constant times cost. This is a variation cost. It will vary with the yield. So we can see as the yield growing, the cost is just a symbol, but we can see it is vary up and down. So we can derivative of this function, and we define the derivative of this function equal to 0. This is the first derivative. So we can see we have the highest point. So which means that we should avoid of this value because it is a very, very high cost. And second is application of the derivative revenue function. The revenue function, we can use derivative to find the highest revenue. Just like the cost function mentioned above, we can use the same method as before to solve which field configuration can produce the greatest revenue under the current state. As usual, the revenue function will be defined as the revenue response to yield equal to k. K is also a constant times p. P is a revenue function. It will vary response to the yield. And we can see as the yields growing and the revenue up and downs. And the third is the application of the derivative in profit function. In actual production, the optimal production setting obtained by the first two methods and often very different. So at this time, it is necessary to derive the profit function. The first derivation of the profit function can determine the inflection point of its function graph. So after the second derivative, it can be determined whether the inflection point reflects the maximum or minimum profit, so as to obtain the optimal profit ratio. So we can see the profit function was defined as the revenue function minus to cost function. So the first derivative can determine the reflected point, and the second derivative can inflect the reflection points, whether it is maximum or minimum. And according to this, we can analyze this, what exactly value should we put when we in the actual producing procedure. And the second part is the washer method to find volume of a solid of the revolution. For example, if we had an equation y equal to the root power of x, and an area which is bounded with this equation and x equal to 4, y equal to 1, this area is revoluted by x-axis. So how can we calculate this volume? First, we can calculate the external radius, which is bigger x, which is equal to the root power of x. It is a function. And the inner radius r, which is a little r of x, which is equal to 1, it is a constant. And as we know, the disk's area function, calculation function is pi r powered of 2. So we can use this function to calculate its area and integrate. So it is pi bigger r of x square and minus pi small r x square and integrate. So the volume can be calculated where a equal to 0 and b equal to 4. So the volume is equal to 4 pi. And in the third part, I will explain the moment and the center of the mass. First is the definition. The center of the mass is a geometrical center of the mass distribution of the object. The moment is the product of the force and lever arm. If we have a seesaw, as the physics knowledge taught us, it is to keep balance just as a consequence, which is x1 times m1 equal to x2 times m2. And this is x1 is the distance, and this is x2 is the distance, and m1, and this is m2. And we can abstract it to the two-dimensional line. And so x1, x2, this is x bar. X bar is the balance point. So the x bar is m1 times x1 plus m2 times x2 over m1 plus x2. Abstract it to the three-dimensional, this is a place. We have x-axis and y-axis. So x bar equal to this. And we can simplify it to the sum of the xi times mi over the sum of the mi. And the y bar is equal to the sum of the mi times yi over the sum of the mi. And the point x bar, point y bar is the center of the mass. And for example, if we have this piece or a disk, we need to calculate its moment or the center of the mass. We can calculate in that way. And if a density is constant, so we abstract a very thin length, a line. So this is the C is the center of the mass, and this is the C to this point, and this is C to this point. As the balance we mentioned before, this is its density is constant. So D1 must equal to D2. So we can get the position of the C. C is x bar point f of x bar over 2. So we can calculate the moment. The moment about the y-axis is rho. Rho is density times the integral a to b f of x times x dx. About the x-axis is the rho is density times f integral a to b over f of x squared over 2 dx. And to calculate the center of the mass, and this is the moment which is to the y-axis and which is to the x-axis. And to calculate the center of the mass, we can use this function we mentioned. We can calculate its mass, its total mass. The total mass function is m equal to rho times s. S is the area. So S, it is easy to calculate. S is integral a to b f of x dx. So m is rho is density times integral a to b f of x dx. When we calculate it, then we can calculate the x bar. X bar is m of y, which is the moment about the y-axis over m. This is moment about the x-axis over m. It is y bar, and x bar dot y bar. It is the center of the mass. Okay, this is all I want to explain. This is the end, and thanks for you watching.